Hello viewers, welcome to another episode of knowledge sharing. For today, we are looking at this question and it says evaluate minus 5 to the power of x equals to 5. So we are going to evaluate this for us to find the value of x from this equation. We are given minus 5 all to the power of x equals to 5. So this is what we have. We are going to use two methods for us to find the value of x. So method 1, which is natural logarithm method. So in this case, this natural logarithm method said that when we have log a base b equals to y, so in this situation, our a must be greater than 0 and our b also must be greater than 0, and also b will not be equals to 1. So these are the rules that are going to guide us for us to find the real solution for the value of x. So we say for real solution, we are given minus 5 all to the power of x equals to 5. This is the same thing as minus 1 times 5 all to the power of x equals to 5. So we can distribute the power. So this is the same thing as minus 1 all to the power of x times 5 to the power of x equals to 5. We recall that when we have in Euler's identity, we have equation where we have exponent I pi plus 1 equals to 0. So when we have equation like this, we are now going to transpose 1 to the right hand side. So this will become exponent I pi equals to minus 1 for Euler's identity. So this is what we have. We can see that in Euler's identity, we have seen that minus 1 equals to exponent to the power of I times pi. So here we are going to substitute this in the place of this. So that is going to give us, substituting that, we have minus 1 to the power of x times 5 to the power of x equals to 5. From here, this is what we have. So substituting this in the place of here, we have exponent to the power of I times pi all to the power of x times 5 to the power of x equals to 5. So this is what we have. So the next step is for us to introduce natural log to both sides. Introduce natural log to both sides. So this will be called ln of into exponent to the power of I pi all to the power of x times 5 to the power of x equals to ln of 5. So in this case, we recall when we have ln of a times b is the same thing as ln of a plus ln of b. Expressing this in this format, this is going to give us ln into e to the power of I pi all to the power of x plus ln of 5 to the power of x equals to ln of 5. So this is the same thing as when we recall. So note, when we have ln of b to the power of x equals to x ln of p. So expressing this in this format, this is going to give us I pi x ln of e plus x ln of 5 equals to ln of 5. So this is what we have now. So we can further simplify this as we have x here and we have x here. They are common. We can factor it out. So this will become x into I pi ln of e plus ln of 5 all equals to ln of 5. So here we can see that we recall that when we have ln of e base e equals to 1, or we have log a base a equals to 1. So this is the same thing as having x into I pi plus ln of 5 all equals to ln of 5, because we can see that we have ln of e to the base of e equals to 1. That means the whole of e equals to 1. That's why we have this. Before we continue, we need to clean this. So we have this. We can say divide both sides by, we divide all through by here. That is I pi plus ln of 5. So this will become x into I pi plus ln of 5 all over I pi plus ln of 5 equals to ln of 5 all over I pi plus ln of 5. So this is what we have. This will cancel here and this will cancel here. We have a value of x equals to ln of 5 all over I pi plus ln of 5. So this is the value of x that we have, and it satisfies this equation. That is for the first method. We are going to look at the second method for us to see. We say method 2, where we have, this is going to be common logarithm that we are going to use. So in this case, we are given minus 5 all to the power of x equals to 5. We all know that this can be written as minus 1 times 5 all to the power of x equals to 5. We recall that our minus 1 is same thing as I to the power of 2. So this is the value of minus 1 that we have. So we used to have square root of minus 1 equals to I. So when we square this, square root of minus 1 will be equals to, we square this side. This will cancel here. We have minus 1 equals to I to the power of 2. So that is why we have I to the power of 2 as minus 1. So this is the same thing as having I to the power of 2 times 5 all to the power of x equals to 5. We can rewrite this as 5 I to the power of 2 all to the power of x equals to 5. Then from here, we can apply log to both sides. That is common log. We need to clean this. So we say apply log to both sides. So this will become log. We have 5 I to the power of 2 all to the power of x equals to log 5. We recall that when we have log a to the power of x is the same thing as x log a. So we are going to express this in this format. This will become x log into 5 I to the power of 2 equals to log 5. And also recall that when we have log a b is the same thing as log a plus log b. Expressing this in this format, we are going to have x log 5 plus, we have here log I to the power of 2 equals to log 5. So this is what we have. So in this case, for further simplification, this is going to give us, we have I to the power of 2 here. So we can express this in this format. This is going to give us x into log 5 plus, this is 2 log I all equals to log 5. So in this case, we are going to divide both sides by here. So when we divide by this equation, we are going to have, they will cancel each other. So we are going to have our x equals to log 5 all over log 5 plus 2 log I. So this is the value of x that we have when we divide both sides by this equation. So we have here as the value of x from the second method, and we also have here as the value of x from the first method. So by comparison, you can see that we have ln of 5 here and we also have log 5 here. So then from the denominator, we have ln of 5 here and we also have log 5 here. Then this other side, we have 2 log I here, and this side we have I pi here. So all of them are equal and satisfy this equation. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share video for more interesting topics. Thank you.